going to learn about the mechanism of current flow, drift velocity, and relaxation time. This comes under the chapter Current Electricity, which is our third chapter. Now, in your smaller classes, you might have learned about substances which allow the flow of current through them. What are they called? Yes, the substances which allow the flow of current through them are called conductors. In solids, conductors are mainly metals. Metals like aluminum, silver, copper, etc. In these metals, there are a large number of free electrons. Now tell me, what do you mean by free electrons? Free electrons are electrons which are free to move. In the case of conductors, you can see that the electrons in the outermost orbit are loosely bound to the parent atom. As a result, these electrons are in random motion. They move in all possible directions. For every electron moving in a particular direction, there is an electron in the opposite direction to cancel its effect. Thus, the average velocity of these free electrons is equal to 0. That is, when there is no electric field, that is when E is equal to 0, the average velocity of electrons, free electrons, is equal to 0 because the electrons are in random motion. Now let's see what happens when an electric field is applied. Now, when you apply an electric field to a conductor, that is, this is the conductor, you are applying an electric field to this conductor by connecting it to a battery. This is the positive of the battery and this is the negative of the battery. Conventionally, the direction of current is the direction in which the positive charges flow. So if the positive charges are flowing in this direction, the conventional current, the direction of conventional current can be marked in this direction. Electrons start moving in a direction opposite to the direction of conventional current. That is, electrons will move in this direction and this direction. In this direction we have the electronic current, and this direction we have the electronic current. Now here you can see the direction of conventional current and electronic current are opposite to each other. So you can say that the direction of conventional current is shown like this. Electronic current is in opposite direction. Now, we follow the direction of current as the direction of conventional current because many theories in physics were developed based on this. Now, you have seen that there is a direction for conventional current, that is from positive to negative. So, let me ask you a question. Is current a scalar or a vector quantity? Is current a scalar or a vector quantity? Now, we can discuss this question based on an example. That is, let's consider two conducting wires. This is a conducting wire, let me call it as AO. A current of 3 ampere flows through this. Another conducting wire BO, a current of 4 ampere flows through this. These two wires are mutually perpendicular to each other. Now, the current coming out through this, let me call it as OC, is equal to 3 plus 4, which is equal to 7 ampere, which is totally based on scalar addition and not at all on vector addition. If it was on vector addition, then the result would have been 5 ampere, which is not happening here. So, current can be very well categorized under scalar quantity. So, from this it is very clear that current is a scalar quantity and not at all a vector quantity. Now, in the case of liquids, let us see how conduction happens. In the case of liquids, conductors are mainly electrolytes. In the case of liquids, conductors are mainly electrolytes. Electrolytes like sodium chloride, silver nitrate solution, copper sulfate solution, etc. These electrolytes, when they are subjected to an electric field, they dissociate into ions. Thus, the charge carriers here are positive and negative ions. Now, in the case of ionized gases, conduction happens because of positive ions, negative ions and electrons. So, now we have seen how conduction takes place in the case of conductors, but there are substances which do not allow the flow of current to them because they do not have any free electrons in them. In these substances, the electrons in the outermost orbit are very tightly bound to the parent atom. Such substances are called insulators. Such substances are called insulators, and insulators do not conduct electricity. Now, taking into account the motion of electrons in a conductor, let us try to bring out the concept of drift velocity and relaxation time. That is drift velocity and relaxation time. When an electric field is applied to a conductor, the free electrons get accelerated in a direction opposite to the direction of the electric field. Thus, these free electrons, they make many collisions with the electrons and the atoms in the conductor. Thus, the average velocity of these free electrons is called drift velocity. Now, you should note that the electric field accelerates the electron, but it does not produce a net acceleration in the electrons. This is because the electrons, the free electrons, keep on colliding with the positive metal ions, and the velocity which it has gained due to the electric field is lost in the next collision. Thus, these free electrons acquire only a constant average velocity called the drift velocity. Now, let us define what is drift velocity. Drift velocity is the velocity gained by the free electrons in a conductor in a direction opposite to the direction of the applied electric field. Now, these free electrons, they collide with each other, and the average time elapsed between two successive collisions is what you call as relaxation time. That is, relaxation time is the average time elapsed between two successive collisions of free electrons in a conductor. It is denoted by the letter tau. So, mathematically, relaxation time can be represented as tau is equal to tau 1 plus, tau 2 plus, tau 3, etc. up till tau n divided by n if there are n number of collisions. And the relaxation time is of the order of 10 raised to minus 14 seconds. Now, With the knowledge of drift velocity and relaxation time, let's try to derive an equation for drift velocity. Consider a conductor having n number of electrons. Let U1, U2, U3, etc. up till Un be the random thermal velocity of the electrons. Under the influence of an electric field, these free electrons experience a force which is given by F is equal to QE, which you have learned in your first chapter. But here Q is equal to minus E because here the charge is electron. So you can write F is equal to minus EE. Let me mark this as equation 1. Now these free electrons experience acceleration due to this force, and it can be written as A is equal to F by m, which is equal to minus EE by m. Here E is the charge of an electron, capital E is the applied electric field, and m is the mass of the electron. Let me mark it as equation 2. At any instant, the velocity of an electron having a thermal velocity U1 is written as V1 is equal to U1 plus A tau 1. Similarly, you can write V2 is equal to U2 plus A tau 2. As there are n electrons, you can write it as Vn is equal to Un plus A tau n. Now, the average of all these velocity gives us the drift velocity. So, drift velocity is equal to Vd is equal to U1 plus A tau 1 plus U2 plus A tau 2 plus etc. etc. Un plus A tau n by n. You will get it as U1 plus U2 plus etc. etc. Un divided by n plus A into tau 1 plus tau 2 plus etc. etc. tau n by n. We have already seen that U1 plus U2 plus etc. till Un by n is equal to 0. So, this expression can be written as 0 plus A into, and this can be represented by the term tau. Now, we have the equation Vd is equal to 0 plus A tau. A can be replaced by minus EE by m. So, you get it as Vd is equal to minus EE by m into tau. This is the equation for drift velocity, where minus E is the charge of the electron, E is the applied electric field, tau is the relaxation time, and m is the mass of the electron. And drift velocity is of the order of 10 raised to minus 5 meter per second. So, today we have seen the mechanism of flow of current through conductors. We have seen what is relaxation time and drift velocity. With this, we come to an end of today's session. Thank you and have a nice day.